Alright, so today we're going to start on trigonometric equations that require factoring. Alright, so start off with one that won't require factoring. Let's say if you wanted to solve 8 cosine squared theta plus 7 equals 11. We're assuming that theta is between 0 and 2 pi. Okay, so the first thing you want to do, you want to solve for cosine squared theta and then solve for cosine theta. Okay, so if we have 8 cosine squared theta plus 7 equals 11, just subtract 11 from both sides. Subtract 7 from both sides. Don't know why I did 11. That cancels out. So we have 8 cosine squared theta equals 4. Divide both sides by 8. Cosine squared theta equals 4 over 8, or you can say 1/2. Might as well go ahead and jump ahead. So divide by 8, divide by 8. Okay. So now if we square root both sides, you have the square root. Remember, that's the same as saying cosine theta squared. So cosine, cosine squared theta is the same as cosine theta squared. You have the square root of 1/2. Okay. So here, the square and the square root cancel each other out. So you have cosine of theta equals square root of 1/2, or you could just say square root of 1 over square root of 2. Which square root of 1 is just 1, and square root of 2 is square root of 2. So if we rationalize our denominator, multiply by square root of 2 over square root of 2, we have square root of 2, well, plus or minus, forgot that part. So it should be plus or minus. Move that over a little bit. So it should equal plus or minus square root of 2 over 2. Okay, so we know that cosine of theta can equal square root of 2 over 2, and cosine of theta can equal negative square root of 2 over 2. Okay. Now remember, cosine theta, that's just your x. That's your x value. So x is positive in quadrants 1 and 4. Okay, so cosine of theta is positive in quadrant 1 and 4. And x is negative in quadrants 2 and 3. So sine of theta is negative quadrant 2 and 3. Okay. So in quadrant 1, cosine of theta equals square root of 2 over 2 is true for power over 4. And theta equals 7 pi over 4. Oh, clean up that pi a little bit. Okay, so this is your quadrant 1, and this is your quadrant 4. Now cosine theta equals negative square root of 2 over 2. It's true for theta equals 3 pi over 4. Remember, that's in quadrant 2. And 5 pi over 4. That's in quadrant 3. So really, all 4 of these will be your answer. So that means theta equals pi over 4, 3 pi over 4, 7 pi over 4, well, 5 pi over 4 and 7 pi over 4, if you want to put them in order. I don't think Newton has a thing about them being in order, but just in case they do. Okay, so those will be all the solutions for theta. All right, so any questions on that one? All right. Okay, so remember, whenever you have your positive and negative values, you always want to make sure you have the right quadrants. Oops, slide that over a little bit. Bless you. All right, so let's say for our next example. So if we wanted to solve 8 sine squared theta plus 8 equals 16, where theta is between 0 and 2 pi. All right, so just like you did for the one before, your first step is you're going to solve for sine squared theta and then solve for sine theta. Okay, so if we have 8 sine squared theta plus 8 equals 16, we subtract 8 from both sides. That's 8 sine squared theta equals 8. If we divide both sides by 8, sine squared theta equals 1. So if we square root both sides, here the square and the square root cancels each other out. So we have sine of theta equals plus or minus the square root of 1 or plus or minus 1. Okay, so that means sine of theta equals 1, and sine of theta can equal negative 1. Okay, so you know this one is true for theta equals pi over 2. And we know this one is true for theta equals 3 pi over 2. Okay, so since those are really the only values between 0 and 2 pi, of course you can add 2 pi and go in the same spot, but between 0 and 2 pi, those are your only two solutions. All right, so any questions on that one? All right. So those are two examples of the ones you didn't have to factor. You just really had to solve for your trig function, and then find the theta that made them true. With these coming up, you will have to do a little bit of factoring, but there is a trick to it. All right, we're still writing. All right. Okay, so what if we wanted to solve 6 cosine squared theta minus 13 cosine theta equals -5. And again, if theta is between 0 and 2 pi. Okay, so the first thing we're going to do is just bring everything to the left-hand side. So we just add 5 to both sides. So you have 6 cosine squared theta minus 13 cosine theta equals 5. Oh, minus 5. Nope, not minus 5, it's plus 5 equals 0. I'm jumping ahead a little bit. All right. Now here, a lot of times it will help. So to solve, it sometimes helps to replace your trig function with a variable. But that's only if you have just one trig function. If you have different trig functions, we'll get to that in a second. Okay. So just temporarily, we'll let cosine of theta equal x. You can make it x, you can make it y, you can make it r, n, whichever one you want, because we're going to change it right back. Okay. So instead of 6 cosine squared, we end up with 6 x squared minus 13x plus 5 equals 0. Okay. And there you can just factor that any way you want to. So factor using any method. Okay. Now once you factor, you end up with 3x minus 5 times 2x minus 1 equals 0. Okay, which means that your 3x minus 5 can equal 0, or 2x minus 1 can equal 0. Okay, so if we add 5 and divide by 3, x can equal 5 over 3. Or, if we add 1, then divide by 2, x can equal 1/2. Okay. Now, once we solve for our x, now we plug back in our cosine of theta. Replace x with cosine of theta. Okay, so that gives us cosine of theta equals 5 over 3. or cosine of theta equals 1/2. Okay. Now all you have to do is solve for both of those. Now the one trick you can look for is whenever you have a cosine theta equal a number bigger than 1, it's automatically no solution. Because remember, cosine theta just goes between 1 and -1. So this, no solution, since cosine of theta, and same with sine of theta, it has to go between 1 and -1. Now you can multiply it by a number and have it go higher than that. But the cosine of theta and theta themselves are just between -1 and 1. So if you have a value that's larger than that, it's no solution. So this one is just no solution for that particular one. Okay. Now this one, this is true. Well, actually, let me write one other small note in there. Bless you. Just give it a little more space. Remember, this is a positive 1/2. So cosine, remember, that's your x. So x is positive in quadrants 1 and 4. So cosine of theta is positive in quadrant 1 and quadrant 4. Okay, so that means this will be true for theta equals pi over 3. That's your quadrant 1. And theta equals 5 pi over 3. That's your quadrant 4. So those are your only two solutions. Okay. And remember, to get your 5 pi over 3, you're just using your reference angle from quadrant 4. All right, so any questions on that one? All right. Leave that up for a few seconds. All right, so for our next example, let's say if we wanted to solve 2 sine squared beta equals 7 sine of beta plus 4. And we know theta is between 0 and 2 pi. Okay, so just like before, we'll or better yet, we'll replace temporarily sine of beta with x. Or you can replace it with y, doesn't really matter, whichever one you're comfortable with. Okay, so now, instead of sine beta squared, that would be 2x squared equals 7x plus 4. Okay. So then we just bring everything to one side. So you have 2x squared minus 7x minus 4 equals 0. And factor using any method you want. Okay, so that gives you 2x plus 1 times x minus 4 equals 0. X minus 4 equals 0. Okay. Okay, so we know that 2x plus 1 can equal 0. Or x minus 4 can equal 0. Thinking ahead too much. X minus 4 can equal 0. Okay. So if we subtract 1, then divide by 2, x can equal negative 1/2. Or if we add 4 to both sides, x can equal 4. Okay. So now we just go ahead and replace our cosine, our sine of theta in this case. Okay, so we have sine of theta equals negative 1/2. Or not theta, using beta on this one. Or sine of beta equals 4. Okay, so the one on the right, automatically toss that one out. Don't even have to worry about that one because it's bigger than 1. Or if it's bigger than 1 or smaller than negative 1, it's no solution. Since sine is between negative 1 and 1. Okay, which means we only have to worry about the one on the left. Okay. So remember, sine is your y. Because remember, that's y is equal to sine theta. And that's negative. So we know sine is negative in quadrants 3 and 4. So sine of beta is negative. And give that a little more room. Let's say quadrant 3 and quadrant 4. Okay, so we just have to figure out the beta in quadrants 3 and 4. Okay, so we know that sine of beta is equal to 7 pi over 6, or sine of beta equals negative 1/2, when beta is equal to 7 pi over 6, and that's in quadrant 3. And beta is equal to 11 pi over 6. That's in quadrant 4. Okay, so your beta is 7 pi over 6 and 11 pi over 6. All right, so any questions on that one? All right. Leave that up for a few seconds. Okay. Okay, so let's say if we wanted to solve 4 times tangent squared beta plus 4 tangent of beta equals 0. And that's saying that beta is between negative pi and pi. Okay, so here we have just tangent. So we can do like we did before and just replace it with a variable. Okay, so that gives us 4x squared plus 4x equals 0. Okay. which means we can factor out a 4x. So you have 4x times x plus 1 equals 0. Okay, which means you have 4x equals 0, or x plus 1 equals 0. Okay, so we divide both sides by 4 here. X can equal 0. Divide both sides, well, subtract -1 from both sides. X can equal -1. And you just replace your variable. Replace x with your tangent of beta. Okay, so replacing the variable isn't necessary, it just sometimes make it easier to visualize. So if you can do it without replacing it, you're more than welcome to do that. Okay, so you have tangent of beta equals 0, or tangent of beta equals -1. Okay, so remember, tangent of beta is just sine over cosine. Okay, so for tangent of beta to equal 0, sine of beta has to equal 0. And it has to be between -pi and +pi. But it can't actually equal pi. Okay, so we know that sine is equal to 0 when beta is equal to -pi, 0, 1 pi, 2 pi, 3 pi, 4 pi, etc., and so on. So the only ones that fall in that range is -pi and 0. Okay, so this one true when beta equals -pi and beta equals 0, because that will make our numerator 0 here. It said the only reason we couldn't use positive pi is because you have a less than and not a less than equal to. So just having that less than means we can't use pi. Okay. Now for tangent of beta equal -1, that means both of these has to have the same beta, but they have to be different signs. So one has to be positive, one has to be negative, which is only true for quadrant 2 and quadrant 4. Because that's when your x is negative, y is positive in 2, and your x is positive, y is negative in quadrant 4. Okay, so in quadrant 2, let me see. Let's see. We know that sine of pi over 4 is square root of 2 over 2. And cosine of pi over 4 is square root of 2 over 2. Okay? So that's why we know that they will always be the same. They'll always give you 1. You just have to figure out which quadrant. Okay? So it's true when beta is equal to -pi over 4. Because remember, our -pi over 4, since sine is an odd function, that negative would just go out to the front. So you have negative square root of 2 over 2 over square root of 2 over 2, which is -1. And beta equals 3 pi over 4. Okay? Which in quadrant 4, cosine of beta is equal to negative square root of 2 over 2. So you have negative square root of 2 over 2, or positive, no, that's quadrant 2. Mix those up. So this is quadrant 4, this is quadrant 2. Sorry about that. Okay, so your answer will equal, if you want to put them in order you can, you don't have to, -pi, -pi over 4, 0, and 3 pi over 4.